Hello and welcome everybody to another Big Data London webinar. Today we're talking about self-service product analytics with Treatwell and Snowplow. So I'm Andy Steed, Content Director of Big Data London, and I'm joined today by Aidan from Snowplow. Hi Aidan.
Hi there, nice to meet you.
And Jeff from Treatwell. Hi Jeff.
Hello, hello.
So these sessions are designed to be interactive. Please do ask as many questions as you like using the question function at the bottom of your screen. I'll endeavour to ask the guys as many as I possibly can in the Q&A section we've got dedicated to after the main presentation. Just a quick note of housekeeping. If you lose the stream at any point, you shouldn't, but just in case, if you just hit refresh in your browser, you'll jump straight back in. So without further ado, I'd like to throw it over to our feature presentation. Over to you, Aidan, to start.
Okay, perfect. Thanks very much, Andy. I guess my name is Aidan. I currently work at Snowplow, but spent 2 years before this working at an open source Snowplow user, the food box company Gusto. And I guess we're here today to talk about self-service product analytics in practice. So in terms of the agenda we've got in place for today, we wanted to start first of all with an introduction to the problem space. From there, I was going to speak for about 15 minutes on sort of general approaches to the technical problems we see related to this concept of self-serve product analytics. And then also related to these technical problems are organizational problems. And this is maybe a generic approach that that Jeff will be able to provide more insight into how Treatwell actually tackled self-serve product analytics in practice. And then after we're done talking, there'll be a chance to ask some questions. So I guess without any further ado, let's begin with an introduction to the problem space. So we at Snowplow see there being 3 different types of data. So we have transactional data, which is generated by servers speaking to each other. And that's things like a typical users table or orders table. We have demographic data, which is generated by organizations like Nielsen, which can be used to maybe enrich transactional or other different types of data. And then what we're here to talk about today is behavioral data, which is data that's collected client-side from, say, web or app interactions. And in terms of the behavioral data that's available, I guess the simplest sort of event you might look at is something like a page view event, but there's all sorts of different interactions users can perform on your different products or apps. Some of them are listed here, like taking a screenshot or opening a newsletter. And we want to explain how it's possible to self-serve insights from all of the events that it's possible to capture from all of the tracking on all of your different applications. So in order to start self-serving product data, we need to actually have product data. So how do we do that? First of all, we need some kind of tracker protocol. So first of all, we might need a tracker to track data from our website, our application, or might use a pixel tracker to track, say, email interactions or banner ad interactions, or we could use, say, third-party webhook to track interactions in other apps. Once the data has been tracked, we need some kind of infrastructure to collect the events and the data. And the way this infrastructure is set up can vary. So this is just the Snowplow way of doing it, but invariably at the start you have a collector to collect the events, and then from there the other 2 steps are kind of optional, but Snowplow likes to validate things up first using JSON schemas to make sure that the event doesn't contain any information that we're not expecting it to contain. And then also we like to give our clients the option to enrich their data using a variety of first and third-party data sources. And then once the data has been tracked and processed by the infrastructure, at this point, the data gets loaded to a destination where users can access the data. So this could be any one of the big data warehouses. So this could be Redshift, Snowflake, BigQuery. And generally what we see to begin with is events will get loaded into a raw event level atomic data set, and then analysts can query this data to generate insights or visualizations or feed into machine learning models. So this is good, but there are some problems with this approach. So by taking this approach, the product team depends on other teams, and being reliant on other teams slows down the generation of product insights. And without these insights, we're kind of blind around which direction should we go to improve the product. And that can have an impact on business results. If we're, for example, unable to optimize our conversion funnels, then that could mean we're unable to optimize revenue generation. But the product teams generally depend on two people to help them with their behavioral data. They're dependent on a front-end team that implements tracking and an analytics team who query the collected behavioral data. And so many organizations will instead opt to enable their product teams to do self-service of their behavioral data. So in the before state, we have the situation where a product manager will speak to a front-end developer, will implement tracking, and then that tracking will lead to events being sent to the data warehouse, from where the product manager can speak to an analyst to generate insights or visualizations or so on. And so we've got a product manager in the middle of these two groups and bottlenecked by them, essentially. And then maybe as the organization grows, then there'll be the need to document some of the processes that are taking place, and there'll be need for maybe a data dictionary or JSON schemas to help product managers, front-end developers, and analysts across all different teams speak the same language. So what if we could improve this process to reduce the amount of reliance product managers have on these separate teams of front-end developers or analysts? Well, that's possible. With, for example, we could get our product managers to replace, in part, our front-end developers using tag managers like GTM or Telium. And then this way, the product manager can generate events on the front end that get loaded into the data warehouse. And with the help of data modeling tools and BI tooling, product managers can self-serve insights from the behavioral data. So saying that sort of this can be achieved with data modeling in itself maybe skims over quite a few key details. So what I really want to do now is to focus into this area of data modeling and explain what data modeling looks like to an organization like Snowplow, or what it looks like for the clients that we work with. So what we've got on this slide here is a depiction of our idea of a preparatory data model. So it takes events from the events table and it aggregates them up to the next level of aggregation, which in this case for web data is page views. And then from there, the sessions table is dependent on aggregated page views data. And this is a preparatory incremental model that doesn't scan the entire atomic events table. So that way it reduces cost, and it contains core business opinion about what constitutes maybe a conversion or a bounce session. And even this proprietary data model by itself is quite useful, because from this we can do simple self-service like querying the page views tables to see how many page views there are by geography, or querying the sessions table to see how many sessions there are by device, or seeing how many sessions there are that bounce by device. But really, what we want to do is go one step further than this and build out an analytical data model. And I've got some examples of what this might look like here, where, for example, we might build off our derived sessions table to create an attribution models table, or we might build off our page views table to build a funnels table. And generally, these are a little bit different from the proprietary incremental models. Generally, they contain significant opinion, not just your core business opinion. Often they're regenerative, so they're drop and recompute, and they can be used for advanced self-service. And I really want to spend the next few minutes just digging into one example of how you could use something like a funnels table for this idea of advanced self-service. So if we consider the example of sort of multipath funnel analytics, what we're really interested in doing is taking something like this diagram on the left-hand side of the page, where a user starts with a particular intent and then navigates through a series of pages to either arrive at some kind of conversion or end their session on some other page. And we want to take this diagram here and turn this into some kind of queryable format that our product managers can derive insights from without too much trouble. And this does actually require quite a bit of thinking and effort up front. And it does require as well analysts or analytical engineers who have domain knowledge of the business to be able to create. But if we do have this willingness to do this work, and if we do have these analysts, then it's possible to arrive at a table like the one on the right-hand side that's capable of answering a whole load of questions. So these questions include, for example, how many sessions end immediately after visiting a product listings page, or how many sessions end after viewing, for example, a single product. So if we just take these first two questions, then we can actually take a look at how we've translated this diagram on the left-hand side into a data modeling table that can be used for very simple self-service, and how with only 4 lines of query, we can answer this first very simple question of how many sessions ended immediately after visiting the product listings page using this query here. And this is the kind of thing that maybe, say, someone in a product team could learn with an afternoon of training in SQL and training in the data marts. Equally, if SQL isn't your bag, then you can always use drag and drop tools. So if we look at the second question we had highlighted on the previous slides of how many sessions end after viewing a single product, then a drag and drop tool could be used equally as well as this simple SQL query here to help our product teams to self-serve insights. So I guess that's the how-to. And then in terms of sort of generic, what do we see in self-service data modeling systems and just general self-service systems overall? First of all, we see there being product data. So we need to have trackers and we need to have a data pipeline that processes this data and puts it into a format that's accessible. We need to have data models that then get created, that can then get turned into some kind of data mart that's possible for users to query from. We need documentation to explain what is being tracked, how it's being tracked, what fields mean what in the data models and the data mart. And then we need some kind of training for the dissemination of this information throughout our organization. I think one key thing that's kind of difficult to get right is this concept of auditability. So we want to generate data sets that are going to enable our users to actually ask questions of the data. So we want to add as many degrees of freedom as possible into these data mart tables so that the end user can ask lots of questions and generate lots of insights in a simpler way as possible. And so that by doing that, they can gain lots and lots of value from the data, and that way that incentivizes them to come back for more data in the future. And then I think finally, it's important to highlight the importance of SLAs. So really, like where does the responsibility of, say, the data engineers end, and where does the responsibility of your product team begin? To what level, for example, do you expect your product team to know SQL? Or to what level do you expect them to be able to self-serve the data from the self-serve tool? What documentation does the data engineering team make? And if there's a feature request to improve the data modeling tables, how long should it take for the data engineers to do that? So that's just a really quick overview of sort of the general approach that Snowplow recommends for our clients. But I think to actually see this in practice, I'd like to hand over to Jeff. So maybe I will stop sharing and allow Jeff to share.
Awesome. Thanks for that, Aidan. Really teed me up nicely to talk a little bit about how we think about self-service at Treatwell. Just to introduce myself a little bit, I'm Jeff Sloan. I'm a data product manager at Treatwell. Specifically, what that means is I'm thinking about kind of two parallel tracks, two really important interlinked tracks. One is what data sets do we need to answer our most pressing business questions, as well as what tools and infrastructure are necessary to support both our tech as well as our product objectives at the business. And I'll speak a little bit more about self-service in practice. Let me just go and share my screen. All good? If I can get a note from Aidan or somebody that you can see my screen, that would be great.
Oh yeah, that's good.
All good.
Fantastic. So I'm really going to be speaking about the stuff around the tech. Aidan did a great job of speaking around technical practices and going into a little bit more depth around how to track behavioral data and what that really means, the data modeling steps necessary, the assets you might create. But I'm going to talk a little bit more around, say, just at the 9,000 foot level of what are we really trying to do? How do we organize our operations and our organization so that way we can actually facilitate tracking this data and using this data effectively. So specifically, there's going to be 4 little pieces that I'm going to talk about. Just again, goals for product analytics and what we're thinking about when we're talking about product analytics, as well as what we don't try to do and what we're not going to talk about today. The second thing I'll speak about is around our operations and org choices, why we made specific decisions to enable self-service at Treatwell. Third, we'll talk a little bit about the uses of technology at Treatwell, so specifically who's using what and who's responsible for what. And then we'll talk a little bit about what do we see as next steps for our use of product data, as well as some challenges and scaling points that we've noticed at this phase. We're a growing scale up. We implemented Snowplow and we're very happy Snowplow customers for years. But now that we're at where we are, what do we see as next steps to get even more value out of data? So before we jump into any of that, I'll just jump right into the takeaways. If you fall asleep for the next 20 minutes, if you black out for the next 20 minutes, if your internet cuts out, these are the 3 things I want you to walk away with. 1, it works. Seriously, feel free to hand the keys as much as possible to the product teams. If your organization looks a little bit like ours, I would highly, highly recommend it. It's been effective at driving innovation in our individual product teams. 2 is that in order to make this happen, data modeling agility is key. We have multiple product teams tracking all of this data in different ways. In order to get this data to conform to those data models that Aidan was speaking about, there needs to be business logic implemented to conform those to sessions and users and funnel steps. And finally, there does get to be an element where the data team, as platform providers, we too are consumers of offerings offered by our platform team. So the ownership question is starting to get a little bit messy at this phase. Who owns what particular parts of, say, our AWS configuration? How should we manage that? None of this has been like a showstopper for us. Our teams are very collaborative and we're able to get over those hurdles. But as we grow, it's something that we're seeking to solve. So let's get into the goals. What are we really trying to do with product analytics? And what are we trying to do with data? When we think about self-service, I'll just make it very, very clear. We're really thinking about, on our side, self-sufficient autonomous product teams that have the ability to move as quickly as possible, gain the domain expertise necessary to to solve the challenges that they're facing with their particular users, and not necessarily individual autonomous product managers or business users. We really do see it as a collaborative team effort, but in service of what? When we go up a level, we think about just 3 broad brush ways of using data. And in our case, we think about it as 1, you can use data to make better decisions. 2, you can use data to enable operations, say like enabling a third-party partnership by exporting data, or enabling your account management team to see whether or not a particular customer has used a feature when they reach out to you for support. And finally, we have the building of data products. If we're talking about the buzzwords of AI, ML, we're talking about the building of data products here, like personalized recommendations, personalized search results. However, what we're going to talk about today, and what we've been very focused on at Treatwell, is the first, helping the business to make better decisions. And this is probably something that we're most familiar with as an industry. And it actually just so turns out that focusing and having this as our leading light enables us to do some of those other things. And the technical world is changing in a way that taking an approach and taking a technical approach that really solves the first is helping us to solve the latter. But we're not going to talk about that. That's a different talk. We're going to talk about the first and really break that down. So when we talk about making better decisions, what are the key outputs? What are we really, really talking about? And in our world, we're really thinking about 3 key analytical outputs. 1 is self-service reporting. So in our case, we use Looker as our business intelligence tool. So self-service reporting is oftentimes used just to generate shared context and understanding. Are we on track to our goals? What's happening in this area of the product? Generally, this is used to generate context and hypotheses. Do we need to be concerned with this area of the product? Do we need to be concerned? Or are we actually overachieving in some area? And why is that happening? Are there more levers that we can lean on? Generally, the reports are the kind of first point for us to start thinking about these questions and diving a little bit deeper. Naturally, that leads us to start asking questions that are a little bit more complex in nature to analysis, which is the second output that we seek to drive. This oftentimes takes the form of some statistical work computed in a Jupyter notebook or in an R script. Sometimes it's actually just dealt with in vanilla SQL, but ultimately it seems like it always ends up in a PowerPoint presentation or a set of Google Slides to recommend a specific action for the business. And the final thing that we think about in better decision making is to enable experimentation. And the classic version in products is A/B tests, and I won't really dive into that. But in order to achieve these, what are 3 particular steps, or what are the steps that are necessary to enable product teams to self-serve and to achieve in order to get to these outputs? And we really think about it as 3 particular steps. So 1 is the tracking step that Aidan referenced, the tracking of behavioral data. Oftentimes, actually, this tracking for product teams is behavioral data. It's not necessarily data or interactions that result in an artifact in a database. It's whether or not somebody paused a video or scrolled down to see a particular form of content at the bottom of our website. This is information that we're thinking about often in our products. The second is the modeling and cleaning of that data. Aidan walked through how that can be a complex or as simple of a process as needed. When we're thinking about that, we're oftentimes thinking about star schemas and Kimball data marts in our world. And finally, we have the use of that data. So actually interacting with that warehoused data, that clean data, in order to drive reporting or better decision making. However, this gets pretty complex in an organization with 9, and honestly, probably 9+ at this point. It's tough to keep track necessarily about how our teams are changing with 60 to 80, maybe even more at the point that, after this slide has been generated. And they're asking both hyper-specific questions as well as hyper-generic questions. And what I mean by that is something to the tune of a product team saying, I want to track engagement with lookbooks. Lookbooks is a new product feature that we've enabled at Treatwell. It's really cool. Enables stylists to post photos of what the treatments look like. That's really nice. But we also didn't really have that information even when we were approached to understand lookbooks. So on one hand, we want to help and we're excited by this product feature, but we know we don't have all of the context necessary to even think about what does engagement even mean with lookbooks in the first place. However, we know that that individual product team has a strong understanding about what they want to track, what an engaged lookbooks user means for them. We want them to be able to answer those specific questions. But on the other hand, we always have the classic, more generic question of, what's a session again? How is that calculated? These are data assets and data questions that every single product team is surfacing. So at this level, we want to enable autonomy. We want to enable people to get through that three-step process to answer questions as quickly as possible, both in the specific case as well as in the more generic cases, and to leverage information from the more generic cases to help them solve these specific questions. Which gets us into operations and org design. So inevitably, once we get to this point of complexity where individual teams have a lot of context and maybe a more centralized data team is kind of scrambling and trying to prioritize amongst all these different competing interests and questions, we end up in the world of deciding between an embedded analytics model and a centralized analytics model, where an embedded org design features analysts that live and report into functional teams, so within their product teams, or say within the marketing team, or a centralized center of excellence model, where people come to a central data team and ask a question and say, hey, how many sales from people named Jim that were born between the hours of midnight and 1 a.m., how many of those did we have yesterday? And the data team has to go away and figure out the answer to that question. At Treatwell, we decided on favoring a hybrid but mostly embedded analytics model for the reason of empowering teams that have the context necessary to make the decisions around prioritization and answer business questions as effectively as possible. And the benefits of the embedded model are that analysts and product teams are able to develop a deep domain expertise in their users, in their data, and how to kind of leverage both of these to innovation by having all of the resources, human resources and skills within the team. They're able to operate autonomously, which means that there are less bottlenecks on individual other teams. Again, they're also able to own the prioritization. The individual teams have a strong understanding of what's the most important to them and why, whereas there's a significant level of context that needs to be shared for a central team to make that same prioritization call. However, we're also aware of really great benefits on the centralized side, and that includes enforceable standards, because you can manage everybody to document and test and do specific things according to a centralized process. There's more knowledge sharing as the analysts are more shared amongst all of the teams and they're spidering across all the different data sets. And finally, there's a pretty clear career path for analysts in more of a centralized model. They can see themselves progressing from junior to mid-level to senior to staff in a way that's a little bit more complicated or a little bit hazier in the embedded model. If a product team or if a product function has 2 or 3 product analysts shared amongst the entire product org, where does a product analyst manager or an aspiring manager, how do they kind of grow into that point? And when does that happen? So we ended up taking a look at both the benefits of this and thinking about about organizing ourselves accordingly so we can try to get the best out of both the embedded and centralized approach, but predominantly we're thinking embedded. And the reason for that, there's a whole nother business out there outside of product. We have marketing, finance, strategy, operations personnel that are all asking business questions. And in an organization that's growing and changing and moving as fast as we want it to, we know that it's hard for a central data team to gain the context necessary to answer those questions effectively. At the moment, we have a core team of about 4 people, though we're looking to grow that. However, still, that's particularly challenging to really understand. I mean, I won't go into the depths of attribution and how to when to use specific attribution models, but that is worth 1,000 white papers, and there's a ton of expertise devoted to that. To gain that context as a centralized team is really challenging, and especially to gain that context outside of the particular use cases that the marketing team has, it's also very, very difficult. So again, I want to take us back to this diagram of tracking, modeling, and using the data, because in this world, what we're thinking about is how can we enable our product teams, again, we'll not focus on those operational teams and the other teams, to be able to make their way through this process step by step on their own. And to do that, we evolved to a compromised tiered approach. This is the hybrid approach that I was speaking about. So in particular, the front line of decision-making and getting answers out of our data involves Looker and the analyst that is embedded in that function. In particular, let's say a particular product team. So if a product manager has a question about how many users used X feature, they'll either have that reporting and dashboard available to them, or they can generate that within a BI platform, or they can ask an analyst who's very intimately familiar with the data set and where to find that information. These individuals are predominantly using Treatwell's tools and existing data to recommend actions and moving as quickly as possible using those. Those individuals do have the possibility of contributing back, say, data modeling logic and additions, edits to core data sets, because they're at the fringes and aware of the changes that need to happen. But at that point, we start entering into the realm of the second tier, which is business intelligence. And here you can also, in your mind, if you're thinking analytics engineering, you could also think about that. You can also just kind of replace the word business intelligence with analytics engineering anytime I say it. In our minds, we think about them functionally the same. These individuals are building core data sets and supporting analysts to spider across our entire data ecosystem. So using the different tools that are available, or hey, a product analyst needs to work with an operations data set and they're unsure about how to join these particular sets of data together. Our BI team / analytics engineering team or function is thinking about how to support those analysts. And then finally, we have the third line of data engineering that are building and managing tools for scale. So the nice thing about this, I mean, at the moment, our analytics engineering / BI function and our data engineering functions are on one combined team, is that there's a very clear feedback loop where analysts want to be as autonomous as possible. An analyst is very much driven to achieving the answer to that question, moving their particular product line forward. And when they're unable to do something, or they have questions on how to do something, that comes down to the BI layer. We're able to think about, okay, what core data sets or what tooling do these individuals need? And then finally, on the data engineering side, again, what key capabilities can we enable, what infrastructure, what technology solutions exist to enable those analysts to achieve, to enable business intelligence, even to serve their users even better. So let's get into how these pieces, these people, all interact with the technology choices that we've made. We, again, we've used Snowplow, but this is how it all comes together in practice. We use a classic ELT paradigm where we load data into a central data warehouse. We clean it all up, we model it, and then we present the clean data in clean tables that are accessed by analysts, either using Jupyter notebooks or Looker, for example. But I want to walk through this kind of piece by piece in order to trace the thread of an individual product team having a business question. So at this level of tracking, our product analysts, product managers, engineers, designers are all thinking about what do we want to track and why. They're also going to be involved in this step, obviously, because they're going to be using the data. They have these questions. And also, in the case of the engineers, they might need to surface information to be accessed by Google Tag Manager. These individuals are then tracking the information in Google Tag Manager. That's pushing this over to our Snowplow pipeline, which is validating and also giving our analysts the information as to whether or not, hey, that new event that you've tracked, is it actually landing in Redshift as expected? Is it meeting the schemas that have been, is it meeting the spec of the schemas that have been specified within Snowplow? Then once that data is loaded into Amazon Redshift, our product analysts contribute back via a pull request or a merge request a change to our core modeling logic. Either within, we have a homegrown ETL system, but oftentimes that takes the place of DBT, which is just going to be a change to a SQL script to incorporate a new event into our understanding of what a venue is, or what a user is, or what a session is. At this point, because these are such core assets, and oftentimes we're talking about joining data in or changing core attributes, an analytics engineer reviews that pull request, it gets merged in, and the data gets cleaned moving forwards in Redshift, which is available for Looker, and then again, the kind of scripts of Python and R. Key in this is that the product analyst is involved throughout the entire process. There's one piece of friction that we introduce in this, which is the operational step of having the analytics engineer review core changes. But outside of that, the product analyst is mostly self-sufficient. And instead, they're having conversations with, say, the product team around what to track and why, and also using that data autonomously as possible. In terms of what tools and what interactions happen, we'll take a look at kind of the product and BI space. The product and BI teams are interacting with each other around this common set of tools: Snowplow, Tag Manager, just to be able to track the data, Luigi and DBT to orchestrate and transform the data, and then finally, say, Looker to actually expose the data in reports. And amongst this, our BI/analytics engineering team is able to help our product analysts decide where and how to use these tools. You can imagine structuring data in different ways in Snowplow, which would then mean that the modeling looks a little bit differently, which mean in say in DBT or in our modeling layer, which then means something different for how this gets exposed to Looker. And our BI team, being expert in seeing across our data landscape the different uses of these different tools, can advise our product analysts on best practices to achieve their end result. And what this means for our data engineering team is that they're able to focus much more on AWS configuration, making sure that's one aspect of this, but making sure that all of these tools are playing well together, as well as feeding information back and forth to one another to empower those tools to become even more valuable. And another piece, product analytics and behavioral data. It's probably one of the largest data sets, especially at a growing business, and especially if you're as successful as we have at actually encouraging our teams to track as much as possible and use this data, which means that Amazon Redshift occasionally needs maintenance and kind of help so that way it scales more effectively. We're happy with this flow because the tooling enables the conversations that we think are the right conversations to happen between kind of a central team and these embedded teams. And as I alluded to beforehand, these things might involve thinking about how should we structure the data when we capture it? Where should we model the data? Should that be modeled up front in the data structure when we're capturing it in Snowplow? Should that be modeled within the modeling layer in DBT? Or should that be, say, pushed to the end uses of that data in Looker or, say, in the scripts themselves? Different cases probably lend themselves to, or they do in reality, lend themselves to different approaches. And our BI and product analyst teams are able to navigate that a little bit better. In addition, there's this natural training loop back for the product analysts because they're at the modeling step, they need the review. We can help work with the product analyst to take advantage of development practices made available through the tooling, like monitoring and testing, say adding DBT tests, or the use of the Insights console in order to identify whether or not events are being specified and sent correctly from our website onwards to our warehouse. How to think about using these different tools, because in the product analyst domain, although these users are very, very technical, they're not always exposed to these more DevOpsy practices. Ultimately, what this means, though, is that standardization occurs at our modeling layer. So if we have all these different teams pushing data in, then one team tracks a button click as click_button, and another team tracks it as click button all capitals. That needs to be conformed to a single click button type event. So that way we can track more easily this particular type of event across our different products. We need to clean that data and conform it, accumulate the business logic that is necessary to get these to conform to a single standard. And we're also able to then feed back, again, these best practices around how to structure the data and how to use all of the tools in order to get data through this track model use pipeline as fast as possible. Occasionally, there might be ways in which the product analyst can use existing data structures or features of Snowplow, so that way data flows clean through to end reporting that the analyst can start building immediately. So all of this is great. It's been working pretty well for us. But what's next? And what's next is oftentimes driven by what's challenging. These are good challenges to have, but the particular one I'll start with is shifting left on standardization. So it's great that we have this backstop with DBT in order to model the data and accumulate all this business logic. Fantastic. But even better if we don't have dirty data to clean up in the first place. So while Snowplow at the moment, that we're using Snowplow for schema validation, making sure that events conform to this particular schema, we're not necessarily using it for data validation as much. So that click button case that I mentioned beforehand can and does occur, and it will occur in this kind of centralized world, or in this embedded world. We very much see an opportunity for pushing that a little bit further back to the product teams. So that way clean data can just flow through into the end models. We're beginning to think about, like, do we use Snowplow's existing features for this? Build our own solution for this? Alternatively, there are SaaS products that have begun coming up in the space. Avo and Iteratively are two that come to mind that focus on building, enabling product teams to work on tracking plans and essentially develop schema registries, similarly that yell at the individual development teams, hey, it's click_button, not click button capitals. But if we can do this, we think that this will actually kind of speed the flow from tracking to the use of data and enable our product teams to be even more self-sufficient. And another next step, another challenge is who owns this thing? So Snowplow, we're longtime users of Snowplow. And I said, oh, data engineering is like we're able to focus on the config, and we're able to focus on the infrastructure, and we're able to focus on Redshift. That's a little bit simplistic. In truth, AWS and our whole account and configuration is really owned by our platform team, and we're actually platform consumers, even though we are the data platform and analytics team. So doing both data engineering and business intelligence work. As the data team, we probably have the most autonomy over what goes on in Redshift and how to tune and configure that. And then we also have Tag Manager in the works. Is that owned by the front end teams? But those front enders are distributed throughout the different teams. Is it owned by the platform team because it can impact the performance of the site? And Snowplow is deployed within our AWS account. So that kind of sits in this world of the AWS. So if we need to make changes because Google decides tomorrow that it wants to change how third-party and first-party cookies are distinguished. This is a very, very hot topic at the moment, and we need to make changes within our AWS account to accommodate for those changes. It can be a little bit challenging to move between these different teams and find out where do we need to make the change, who can make the change, et cetera. This is a little bit of a nice to have problem. We want this data to be accurate, and we have stakeholders that are letting us know we need to make these changes. And we're also really lucky that our platform teams are very collaborative. We can work together in order to solve these challenges. The approach that we're trying out at the moment is essentially to have the visibility without the autonomy to make changes, and then we propose changes to our platform team, who can then review and make sure that we're not, say, exposing security vulnerabilities or not at risk of changing how other products and services might be working that are using that aspect and that configuration. So I would absolutely 1000% love if somebody, if people have opinions on this and about how to kind of navigate this change. I think it's a natural kind of thing to happen at this kind of stage in the game, and especially because we're remote, it's a little bit harder for us to kind of shoulder tap, say, hey, we just need to make this change. How best to kind of organize the teams around kind of infrastructure and tech changes. But it's something that hasn't been a showstopper for us, but it's something that we're really looking into and interested in resolving. So I'll just kind of back up again. The takeaways here, it works, and it's worked in the way that we've kind of deployed it. I'd seriously consider evaluating a self-service model and pushing more to the teams. Our analysts have been very, very happy and have stayed with business quite a long time as a result of the self-sufficiency that they can get through tracking all the way to the use of the data. And product teams are, it's pretty rare, to be honest, how often product teams come to the data team or to me as the data product manager to ask how they can ultimately analyze a product feature. Mostly they're just doing that themselves. The second thing is, in order to enable this, data modeling agility is key. We do have this kind of intentional friction point where analysts are having their code reviewed by a central analytics engineering team. But the faster we can get the data through that pipe, the faster our product teams can use that data. And finally, technical ownership. Of course, this is always going to evolve. It gets a little messy at this stage. Not a showstopper for us, but it's something that we'd be really keen to resolve. So in that little kind of chat thing, if you have thoughts, please do post them. And yes, no kind of conference webinar is complete without saying, yes, we are hiring. If anything that I mentioned was exciting, interesting to you, please reach out to me after the talk. We're looking for great analytics engineers and data engineers, and I'd be happy to answer your questions and refer you to the right people. So that is all I have today. Let me just go on to the next one is just questions. I don't know if somebody wants to take the slide away from me, but that's it.
Hi, Jeff. Should we return back to the video screen so we can see yourselves and Aidan? Yeah, that'd be cool. I've got a couple of questions. We've got a couple of questions from the audience too. Thank you both. Enjoyed the presentation. That's goes without saying. Quickly, Jeff, if someone did want to reach out to you, what's the best way? LinkedIn, Twitter?
LinkedIn would be the best approach.
LinkedIn, okay, that's good. And the other quick housekeeping-y thing is, if you missed any of the presentation or you'd like to see any of it again, it's available on demand almost instantly after we finish. So just go in there and it's got a play bar and you can go and rewind and pause on certain bits if you would like to. So now I've got that out of the way. We've got a couple of questions around the sort of structure of the team and stuff. But I thought I'd just quickly ask first. What happens above what we saw? Where do you all report into? Is it like an IT side, or do you have a chief data officer, or do you go straight into kind of some kind of line of business function?
So that is a great question, and I'm going to give you a funny answer. I think data is sometimes kind of it's very much like a pragmatic case of like who can manage this function oftentimes as a nascent field. So, for example, I don't report into the product org. I just report directly to the CTO. But our BI team reports into me, which is again a little bit unusual as a product manager to be both the line manager and kind of product owner within the team. But this is based off of kind of my experience in business intelligence prior to Treatwell. And then the data engineering reports into a data engineering tech lead, also on the team, who reports into the VP of engineering. This could be changing. And it's a topic around like how do we best organize this in order to, should BI actually be a strategy function? Should it remain within tech? I don't think anyone has the greatest answer, so I generally defer to, in our case, it's worked out fine, but I generally defer to pragmatism for organizations in practice, rather than really seeking to nail it on the head with an org structure.
Yep. Yeah. And I'm going to ask you a question, Aidan, about this sort of. I'm going to put it back to more your experience and stuff. So you mentioned Gusto as we were starting, and obviously you're helping companies now with self-service. Gusto obviously is quite famously data-driven in its essence. Treatwell, obviously, as we've heard from them, we've seen them. To make the most of self-service analytics, does there need to be a data-driven culture through the business? Does everyone need to get it? If so, yeah, if you get what I mean.
Yeah, I mean, I guess that's part of what we're trying to achieve with self-service is, I guess we want to end up in a situation where we have a data-driven culture, because I don't know, that's a good thing, and it's a good thing to drive business decisions based on data. I guess, yeah, the question we're trying to tackle now is how we get there. And I really see that partly as like data modeling to allow people to self-serve and ask the questions of the data. And then I guess as well, there's sort of the maybe dual side of that of documentation and training, so that people can understand what is out there that will enable them to self-serve, and they have maybe people they can refer to for help.
Perfect. That's a very, very good point. I'll actually throw that over to you, Jeff, in terms of training, keeping on top of this, all that kind of thing. What do you do at Treatwell? Just to make sure everybody's clued in with everything that you want them to do. Is there a central resource, or do you work with people to come in, or etc.?
So I think that this is again where the embedded model really shines. I mean, in order for people to get use out of data, it's useful to have champions that are within the organization. And just to kind of reference a question in the chat, actually, around kind of the functional analysts, is there enough for them to do? Oftentimes the form of this is one team gets it, and then they start using the data, and given the kind of nature of our setup, we'll help them get set up and get self-sufficient. And then that particular analyst becomes an expert, is able to answer questions very effectively, help train people on how to use the looker reports. And then other teams start saying, hey, we want questions. And then that might then lead to, or we might want to answer questions, and then that leads to, say, the BI team starting to answer or build some initial dashboards, and then they get frustrated that, hey, we've got a taste of answering some of our questions, but we need to be able to move faster, and that leads to the justification for a head and a resource who then takes and owns that and owns the training of that. The step back is that the BI and data engineering teams are focusing on kind of staying abreast of all the changes in technology, and then diffusing the newest knowledge and the newest use of tools amongst those embedded analysts, for them to then decide as to what to do with the individual kind of their individual function, if it's relevant for them to push that even further out.
And what do you find? What do you find meetings are like now within those departments? Are they significantly different to perhaps departments that don't have access to data? Do they have bigger reports, more regular reports? That kind of thing. Are they talking about data much more than they would have done? Do you think things they have access to it, or is it just something they fall back on?
It's always amazing to have somebody that a year ago wouldn't look at a Looker report, all of a sudden saying, "How is that defined? We need to change our definition of a contact." And I mean, I think it's by having a local resource that can help bring them along the journey. It's really important to recognize that this is a new and nascent field, and a lot of people have expertise outside of, say, the use of data. It's incredibly helpful for somebody to be able to regularly work with them and bring them along the journey, so that their understanding of the entire kind of end-to-end view, and especially in product, this is now just becoming table stakes. So our analysts are kind of our frontline in helping product managers really think about experimentation and think about data tracking as a first-class citizen.
Perfect. And I guess I'll end with this question for both of you. In terms of explaining to someone who isn't an expert in data, maybe they're a line of business manager or something like that, and you're trying to explain to them the benefits that this will bring, or trying to explain to them why it's important. What's the best way of kind of explaining to them why they need this sort of thing, why they should restructure? Because it is a seismic change, I guess. I'll give it to you, Jeff, and we'll come back to Aidan, and he can sum it all up for us.
The way that I describe to my grandmother what I do is I help people make decisions with evidence. And there's lots of types of evidence, and there's lots of ways of justifying decisions. Data is one way of doing that. And I think that there's for any business user or business stakeholder that's ever had a question around what to do, or uncertainty around what to do, they're looking for more certainty in order to make the right decision. Data analytics is a solution to that. That's the value that we bring.
Perfect. And how are we convincing people who don't work day to day that this is the kind of, these are the tools they need to be employing, and this is the kind of approach that they need?
I think it's a bit of a tricky question. I think my go-to whenever someone asks me to justify the value of behavioral data is to try and think of maybe the most simple use case that adds the most value I can, which is like the idea of abandoned cart recovery on a website. It's kind of like we've seen use cases like that add sort of incremental 25 plus gross revenue to a company. And it's like, well, you can do that in one afternoon with the right tools. And that's something that's very actionable, very specific. I guess what we're looking at here with the sort of idea of self-service is, well, how can we apply data to every decision we make, and make lots of decisions similar to that are going to add incremental value and just improve the way we do everything.
Perfect. Well, it's been a pleasure to have you both on. Thank you very much for the presentations. Like I said to everybody, do check them out again if you want to. They'll be available straight away. But from us at Big Data London and from Jeff and Aidan, it's goodbye for now. So bye, guys, and we'll see you very soon. Bye. Thanks, Jeff.
Thanks for having us.
Thanks very much, guys.